Welcome back. This tutorial will look at kind of the next step from multi-view projection into 3D projection using successive auxiliary views. These are views that build upon what you've already looked at as an auxiliary view to the primary top, front, side views that we have in our multi-view drawings, and then use those to project into a three-dimensional view. So you can see the object from any side we want to that has strange cuts in it, like our cube here. And this means that we can take something from the top view, look at it in the side auxiliary view, and then project it into a three-dimensional view that points this plane specifically at the camera, which means we get that in true dimension. This is something you've been exploring in your plane oblique and section drawings, where in the top view we know this line is its true dimension because it's on this plane and we're looking directly at that plane. So that I can measure. I go to a side view over here because this line is on this plane, I can measure that line. And similarly in the front view, I can measure that line. But what I can't measure is this connection in here in space because it's always shortened in every view. And that's where you had to cut a section here perpendicular to that plane and project another section off of that to be able to measure the hypotenuse of this triangle relative to its right angle in order to understand its full true dimensions. And there's other ways you can do that, especially if you're getting more complex than just this cutoff, by rotating the object through the successive auxiliary views to project it into a three-dimensional view. The first one we create here will also be an isometric view. So this serves kind of two purposes: to be able to project isometric views, which you'll be familiar with in Rhino, as well as any successive auxiliary view you want to explore so that you can begin to develop sequential views, rotating an object in space to see it from any angle you like. Now I've already got a bit of a setup here that we should be familiar with. I have a top view, a right side view, and an auxiliary left front view. You can start from kind of any position, but there's a few key points here. Some I just need the top and the right for their basic information of thickness, size, and orientation. And you can see that I'm taking my right view around and projecting it over to get this information. I didn't go this way because I want to use this space for my drawing. That's something to consider as you sketch out your compositions. And then this left auxiliary view is very specific to the view we want to take in terms of seeing this object. And so what you'll see is that it's coming straight out from here, right? Parallel to these edges of the cut on our cube, so that in a sense our fold line or projection line here is perpendicular to that. So we have a couple lines indicated there, and that means we're going to be looking kind of directly at the side of this. Right? So we're kind of looking flat on, as if that cut doesn't exist. We just see it as a plane. So we're seeing the plane of the cut right there. And that's important because now that has been changed to its kind of side view of the plane, which means we can come straight out from there and intersect it back with this top view to construct a view onto that plane. But this is all the same tools and techniques as far as projection that you've been using in your multi-view drawings and your sections, and in a sense even in the plane obliques, but with a little bit different result, as we saw in the lecture about axonometric and oblique views. I think the hardest part of this, and you'll see in some of the print tutorials as well, is just remembering to always have your stuff intersect at right angles. But again, that's no different than any of these, right? This is a right angle, this maintains right angles, this does a couple of right angles along the trip, this intersects as a right angle, this intersects as a right angle, so everything is always intersecting at a right angle. If you change that and it intersects at an oblique or acute or obtuse angle, you get distortion in the object. So this might be one where we need to use our adjustable triangle. This is good for this shape because it's at a nice 45. I don't have to worry about it, right? And that comes right there. So I can just stick with this simple 45 triangle. I'm just going to draw over a couple of these lines to establish a base point there. Now the key with this is that we kind of want to mix this view, right? This front auxiliary, front right auxiliary view with the top view with this other side view. So we're going to do that by bringing perpendicular to this front view. And we're just going to project that off like we're going to do that auxiliary view. But then we're going to rotate that so that we can intersect this view, which is now tilted up from the ground. So our cube is kind of sitting like this, which means we're seeing into this face. So I'm going to bring this over. So you always project, and this can be any view. In this case, we're just very specific to this plane here, which is not straight up and down, right? So now this is where I'm going to have to use my adjustable triangle. But we're going to project perpendicular to this. Let's go ahead and find out what that angle is. I'm going to play this little game here, find the best way to rotate this. And there we go. And that'll be depending on what view you're trying to draw. And I need to really work my way around. So here you can see that that is now a perpendicular projection angle. I can project straight out from that plane. I'll just bring some construction lines at my extreme points. I'm going to run out of page here to work, or drafting board here to work with, so keep that in mind. You might need to move up. Some other things you can do, so I can find the right angle, is use, again, a combination of two triangles here, so I can just keep my triangle up in this space and project off of another triangle with the right angle. Now let's get the edges of the plane, and we'll worry about details a little bit later. Right, so that should be my key points, top of that, the end of that, the bottom of that, and then this bottom corner as a starting place. So these are now coming out perpendicular to the thing I want to look at. Right? And again, this can be any angle. Just specifically here, I want to look at this face. So if I chose this angle and came out perpendicular to that angle, I would be looking at kind of a weird corner face. It wouldn't help me measure anything, but it would be another three-dimensional view. Similarly, I could project from this top view at any angle. And this is something you'll be working on in the homework, is you'll project a series of angles. And once I come out from those, I choose how I want to look at it, and I project perpendicular from that. And then we have to kind of bring two views together. You can kind of change one thing at a time or multiple simultaneously when you get the hang of it. So once I've got that set up, then I also want to kind of project straight off of this. Some of that's already been started. Let's just start with our key outer points. Okay. And so somehow I have to get this line and this line to meet at a right angle, which means choosing a hinge location. I've already got one kind of marked here. It's just a little distance out from this top view, so there's room to work. But again, this could be here, it could be way over here. Just depends on where you're going to place the drawing. Since I've already got one drawn here, I'll go ahead and use that, which means where these two things intersect is going to become my potential hinge location. But it could be anywhere along that line. So I actually want to do a little bit tighter curve, right? That's kind of a big curve. I'm going to do a tighter curve right here. Place my hinge right there. Again, you don't have to draw these dots. I'm just drawing them so that you can visualize them. You can kind of do a light marking with a pencil to keep it in mind where you're going. And since I have my adjustable triangle here, I know I want to get around to this other hinge line, right? If this is my door, I'm hinging it around until I reach the angle that I want it to be open at. So it's going to be right there. And this is where I need to kind of swing this line here so I can work back down in this direction and intersect these lines perpendicular. This is where you can use your compass or the angle bisector method, whichever you choose. Things are starting to get pretty complex here, so doing the angle bisector method, you got to take your time and make sure you connect everything correctly. A quick way to do that is just make sure I take this same distance over here and project and find the intersection point, which requires me to come and do a little bit of measuring or projecting from another view, because measuring is never really that accurate. But then I can find it. I'm going to use the compass because I find it just a little bit more straightforward. Start with the big outer one. At some point with a big object, you might need a beam extension to your compass or a bow compass. try really, on the Bristol, it helps a lot. Right? You can get a good puncture with that compass point so it doesn't move around, so you have a nice, repeatable, accurate arc each time, keeping your lead and your point at the same distance. You can get pretty close, but we'll eventually reach a limit. So there we go. And come around and just make sure that's a nice perpendicular angle there. Come on down through. And it looks like I need to do a little bit of extending of some of these lines over here, just to make sure they're all forming up to make my cube. But we have a familiar looking kind of square going on there. So our final drawing will end up here. Right? So I'm doing this on a piece of trace. That's a good way to sketch them out at first. Once you have the system down, you're going to have a sense of where it'll go to. And I might project several more arcs off of this in motion. If you look at some of the examples, you'll see this, or I could tumble out in this way. So how I place it on my page will be important. I have a lot of space between these views, which really isn't necessary. Just kind of a starting point that I had for being able to fit all this other documentation information in. You can start a lot tighter, but then this kind of projection gets a little complicated. So it's somewhere in the middle to find the balance between the views. Okay, so now I've got those lines drawn. Let's just go ahead and bring these other intersections over. Get it kind of specced in. So I can begin to identify what I'm looking at here. So if these, didn't bring that point down. All right, and now this is starting to kind of have a depth or a width similar to this view here on the side. But I haven't brought every line over yet. So another thing that we'll have come into play here is the back corner of our cube. So this drawing actually starts to become quite large as we see it as a three-dimensional view, not so different than our plan oblique. But let's start with this triangle face. Right, so these two edges here come around and intersect there, comes around and intersects there. The center point comes around and intersects there. Again, always at 90 degrees. I'll just keep repeating it, because that's the primary thing you're looking at in multi-view, as well as a successive auxiliary view projection. This is where my triangle is going to end up. And I don't want to mess with my adjustable triangle here, because I'm going to use this angle a lot. So I'm going to go ahead and connect these dots, just using a straight edge carefully, since I only really have to draw them once right now. When I come back, I need to add thickness for the parallel edge. Then I can adjust that adjustable triangle. Right now, just looking at the outer edge of this triangle. And so if I've kind of done everything right, that should be the true dimension of the triangle I have here on this face. Maybe I can kind of line those up. It's a little tricky with the perspective of the camera, but they start to look kind of similar. And I should be able to verify with measurements. All right, that's 1 3/8-ish, and about 1 3/8. It's a little different with some material thicknesses, but that could just be differences with my drawing in there. So we'll go with an averaging. All right, that's between 1 3/8 and 1.5 on each side. So as long as we're the same on each side, we're doing pretty well here in the drawing. Right, so that one is also 1 3/8, and this top one is also 1 3/8. So that means we've got an equilateral triangle here, which is what we know we should have from our cube. It's coming from two views intersecting at right angles. And that means that our cube is kind of facing towards us on that plane. So we've drawn the plane of projection, which is the plane of this triangle in space, which is this line right here. It might always help to kind of draw that in so you know where you're projecting from. All right, so it keeps that in mind. And similarly, that is already on our drawing up here. I'm just going to draw them in kind of heavy so we can see them. And so I'm bringing these two lines together in space. I can change that up and draw a successive one. Maybe I'll do another up over here for fun if we have some time. Let's fill in the rest of the cube and see what we end up with. So here this back corner is the same as the front corner, comes around, intersects right there. Side comes around and intersects with these two corners here and here. So I got to bring those over. And you want a little bit more edge so things aren't wobbly. There we go. And because in this case I don't have the front and the back corners overlap each other, right? It's just one line I have to bring over. But if this cube was at a different angle, I might have to bring over a few more lines, right? Because they wouldn't be directly behind each other. Which means you might need to use your hidden lines. Keep that in mind. There we go. So this edge comes around and intersects this one. This edge comes around and intersects this one. Similarly, this one and this one. But if that line were back here, so it's a different angle, I have to bring both those over. So now I should be able to start to connect some of these dots here, and I need one bottom one, right? So this corner comes over and just meets that corner there. Let's go ahead and connect up those dots. Hopefully we can use our adjustable triangle for a good number of them. Start to make a profile of the outline of this box so it stands out. And this might be a good time to record what angle I was initially drawing at, so I can have a little bit better accuracy for some of these. Or again, if I'm starting to just sketch this in, it looks like I'm at a quite challenging, right there, 10-degree angle on our marker. So that's easy to get back to. And see if we can kind of work this to these points. Because I will have parallel edges, it's nice to use the triangle. That way I'm sure they're parallel. I don't get any visual distortion. And that's at just about 40.5 degrees, 41 degrees. Now it's always a fun game here to figure out how to get to that other angle. And they may all be a bit different. That game was just a sliding game. And then when I want to find this angle, it's going to be adjusted in another way. So you should start to be able to see some of this outline taking shape. We have our back edge there, we have our bottom corner there. It kind of fits right in that space, right? And that's what we're drawing without the perspectival distortion. A few more lines to fill in and we should pretty much be able to see our box. So think about what's connected, right? These 2 points are connected, these 2 points, this point and this point here are connected, and then we'll see our front side, right side, and top of the cube. Again, we can figure out a bunch of adjustable triangle angles. They should share the angles, so kind of being strategic with that can help do the drawing quickly, at least to get the initial line in so it's nice and crisp. And then we got to go back to our original 10 degrees. And these will always be different, so the degrees are dependent on what you've chosen to draw. Now I can kind of see that box coming into place. Need a little line weight adjustment here to kind of bring out this edge of the box right there. The line weight, similar to the plan oblique drawing, is a little bit less straightforward to an elevation view or section view where you're really just drawing depth. Here you have to make a few choices about what you want to see in depth and how that object ends in space. All right, so we're dealing with something relatively simple, but this plane is very important because this is true dimension plane. And since we know our box is 2 by 2 by 2, we can check out like what's happening with our sides, right? Not like the plane oblique, they are not 2 inches, right? They are shortened because we're seeing them at an angle in space. But this plane that we are projecting from in 2 directions, we see true. So these are the only true lines on this drawing. Anything on this plane, which would also mean our offset lines to show the material thickness, which means you could find that little triangle in that quiz. Yeah, after a little bit of quiet drawing, we have some construction outside. I filled in some of the details, but just following the same rules. And you can see that occasionally I need to bring information from the other views down over here, being careful to do it from reference edges that I can see on the exterior of the cube here. But once some of those points are located within the projected drawing here, this successive auxiliary or isometric view, they're kind of one and the same at this point, then I can just project information around the cube relative to its new coordinate system, similar to the plan oblique. And we can start to see I have a top piece sitting on top, a bottom piece down below. I can see this back side panel here, and I probably can check my cube again and notice that like the right ends at a clean edge on both sides, so its edge is in front over here, and there's no double edge back that direction. So we're starting to have an accurate representation of the cube made out of parts, and I can measure everything on this plane, which in this case is really just the outer triangle, because that's the only thing that touches the plane when I've made it in this butt joint method. If you wanted to draw it as a miter method, then you'd have a clean cut there, or if you just draw this as like a cut plane, that's okay. To explore it, it's not about drawing everything exactly as the cube was made out of material, since this is 1 degree of abstraction due to the material you have to make with. This is another degree of abstraction you can use to develop the drawing. That's most things here. The only other stuff I think about line weight is you might give a little bit stronger profile to that outer edge and a little bit stronger profile to this plane cut here to have a little bit of depth between the two. Right now I can pretty well see the cube there in space, and if you have other cuts on your object that are projecting around the sides of it, they'll have to make decisions there of kind of what seems to be closer to you or of stronger value and what is pushed further back into the space. I think one area to focus on having kind of lighter lines is the meeting of material versus cuts or holes in the material, which allow us to see into the back. And notice I didn't draw my back of the cube. This is something with the isometric, right? That the stuff behind in a cube is lined up with the stuff in front. And so this corner here comes all the way around, and really the visible part of it would be that line right in there very, very lightly. And that's really all I could see back there. But that's one of the issues with isometric, is stuff gets hidden quite a lot. But when we go to other successive auxiliary views, we'll be able to see quite a bit more. And I start just a basic setup to look at doing another sequential view, and then we'll let you work on your own. So if this first one, we made our decision based on what we're going to look at the object by looking at this plane, and that corresponds to the specific view straight on, so I don't get any distortion. You can kind of start this next exercise by keeping one of these the same and changing the other. In this case, on my paper, for instance, I could maybe look at, say, a plane like this and bring this over and intersect, and then the object or the view is going to move up this direction. Or make this my primary trajectory here, and I can change this angle, so I could put more views here or more views over here. When we start to block one in over here, so I'll just keep this projection angle the same, and I'll change the way I come out from the primary cube there. This one was at 45, which is nice and convenient.